Tracking surfaces is a difficult task, even in the case when complete scans are available. Due to self-contacts, parts of surfaces are hidden in certain frames, and therefore a tracking algorithm must always consider the possibility that a corresponding piece of surface is simply not present. Tracking volume, on the other hand, is often easier. We present an improved algorithm that is able to process situations with severe surface merging due to contact, as well as other challenging situations. The main contribution lies in quantifying the affinity of the tracked volume elements and formulating the tracking energy in terms of deviation from rigidity within locally affine groups. Centers are considered affine when they are located near each other, and when their movement, represented as a rigid transformation, is similar in previous frames. For evaluating transformation similarity, we use a recently proposed data-induced metric. The proposed method is capable of processing a wide range of real-world data, including non-watertight and otherwise degenerate meshes. Thank you for watching.